Okay, today we're looking at section 7.5, which deals with rational exponents and radicals. Hopefully by the end of this section you can say that I can rewrite expressions involving radicals and rational exponents. Okay, so some terminology that we want to make sure we're aware of. The radical sign obviously is the square root symbol. The radicand is simply the number underneath the radical sign, and then the index would be like our number here, so like the square root or the cube root, the 3 or the 2. If I looked at the square root of 49, or if I looked at the cube root of 27, this number here, those are our indexes. Okay. So, what is the value expression? The first one has been started for you. So, you have to remember again what the square root means. So, if the square root, it really means what number times itself would give you a 36. So, the answer here would be a 6. What number times itself would give you 100? And again, that would be a 10. Okay. For this one, cube root of 64. What number times itself would get you 64? And there is a key on your calculator that you can use, and you should be able to get a 4. You can ask for some explanations on that tomorrow. The cube root of 1 is simply a 1. The fourth root of 256 is a 4. And the third root of 125 is a 5, or the cube root of 125. Okay, easy enough. Okay, so now what we're going to be working with today, we're going to try and rewrite expressions that are in exponential form into radical form. So the first one is set up for you, but the key note that you want to have written down would be up here. So if the nth root of a real number and m and n are positive integers, then this is what we have. A to the 1/nth power would really be the nth root of a, okay, or a to the m over n. Notice my index and the n and the n here, and then the m, or a to the nth power. So, with that being said, let's see if we can work through some of these. So the first one's done for us. The second one, if we work across, I have m to the 4/5 power. So m, 4/5 power, so the index is the 5, and the power underneath is the 4. So it's really m to the 4th to the 5th root. Okay, if I looked at this next one, p to the 7/3 power is really the third root of p to the 7th. Or if I have x to the 2/3 power, that would really be the cube root of x squared. And the last one, if I look here, if we remember our powers of a product, first of all, 25 has to be the 1/5, and then x squared to the 1/2, that's just an x. So really we have the square root of 25, and then times an x. Well, the square root of 25 is just 5, so this is simply 5x. Okay, hopefully so far so good. Now, I want you to try and do these 4, and then pause the video, and then come back on and see how you did. Okay, so this one would have been the cube root of x squared. This one should have been a 15 times the 4th root of x to the 3rd. Okay, this one, the 27 is raised to the 3rd power, and the x to the 3rd, the 1 power just becomes an x. Okay, so what is the 3rd, or excuse me, 27 to the 3rd? Well, that would be like the 3rd root of 27 times an x still, and the 3rd root of 27 is 3. So really what we have is 3x. Okay, this one, 16 has no power, so it just stays 16. And then what we're really looking for is the fifth root of t. So it'd be written like this, 16 times the fifth root of t. Okay. Next one. Now we're going to go the other way. So if I have the third root of x in exponential form, that's really x to the 1/3. Okay, if I have this one, that would be the a to the 3/2 power. Okay, the next one is really 16a to the 1/2 power, or it could be simplified as 4a to the 1/2 power. Okay, and then this next one, I have 49w squared, the square root of that. Well, if we think about that a little bit, the square root really undoes the squaring. So really what I end up with is 49w. Okay, hopefully that makes sense to us all. Okay, next one. So if you want to take a look at this one, see if you can figure out what this one would be. Okay, so this one here would be this. I've got 125. Oh, I gotta 125d squared to the 1/3 power. Okay, so if I distribute that, it's really 125 to the 1/3 power, and it's really d to the 2/3 power. Well, 125 to the 1/3 power is 5, so I got 5 times d to the 2/3 power. Okay, so for this one, I've got the square root of 2m to the 4th. So this would be like, so 2m to the 4th, and then that whole thing is to the 1/2 power. So if I simply distribute, I really get, not distribute, but if I take the power of a power, excuse me, I get 2m to the 2nd power. Okay, well then I just take 2 squared, m squared, so I get 4m squared. Okay. Now, another thing you might have to do today is simplify each expression using properties of exponents, and then rewrite in radical form. So for this one, what are the properties of exponents? Well, we have the same base of x, so really what we need to do is add those exponents. So I simply get a 1. So I get x to the first. Well, there's nothing to really simplify there. Okay, the next one, if I think the same way, adding those exponents, I really get a to the 4/5 power, which really means the 5th root of a to the 4th. So this would be your answer in radical form. Okay, let's keep cruising here. So this one, if I distribute, or not distribute, if I look at the ab to the 1/3, that is really a to the 1/3, b to the 1/3, and then I still have times b to the 1/3. Well, if I combine these 1/3, since I have the same base, I'd have a to the 1/3, b to the 2/3. Well, how can I write that in radical form? Well, both of them would have an index of 3. So my index is 3. I have an a to the 1st power. I have a b to the 2nd power. So this would be your answer in radical form. Okay, this next one, I would have a 16 to the 1/2 power. I'd have an x to the 1/2 power. And I've got an x to the 1/3 power. So I know that 16 to the 1/2 power is really the square root of 16, which is 4. And then if I have x to the 1/2 times x to the 1/3, I really know I need to add these two things. So you got to think about common denominator. So I got 3/6 plus 2/6. So that's really 5/6. So I really have x to the 5/6 power. Well, that's really the 6th root of x to the 5th. So this would be your final answer. Okay. The other way around now. So if I can put them into exponential form and then try and simplify. So if I had this first one, I know I got a 2, and then the a is to the 1/3 power, plus a 3, and then it's going to be a to the 1/3 power. So how many a's to the 1/3 power do I have? I would have 5 a to the 1/3 power if you wanted to write it in exponential form. Okay, this next one, I've got a 3, and then I got a b to the 1/4 power minus a b to the 1/3 power. Well, can I do anything with these? And the answer would be no. So this would be your final answer in exponential form. So hopefully this is all making sense to you. Again, you're going to have to ask some questions if things aren't making sense. Don't be afraid to ask a neighbor as well. So that is a wrap, and happy Math Day.